Welcome to a fantastic edition of Rebellion's educational series. I'm here with one of the smartest minds I've come across in the last 2 decades in technology. Ruchir Puri is the chief scientist of IBM Research. And thank you so much for coming on today.
Thank you, Alex. It's a pleasure to be on. Looking forward to the discussion.
Yes, well, IBM has really been impressing the street the last year. You guys have pivoted to all the right places and growth has commenced again. But I want to get to the news with quantum computing. What about quantum computing excites you the most for its application in society for tomorrow?
I think from a really technology point of view, if you look at just the progression of computing, there have been step functions along the way where the nature of computing fundamentally changed. We went from obviously, computing with relays. So it was a very different computing element to computing with, moved on over to computing with transistors. It was all about miniaturization. And we rode that wave for decades. But we are entering the realm of really, I would say, fundamentals of physics, about the quantum nature of computation itself, as has been illustrated very well by Feynman and other famous scientists. And what excites me most about quantum is applications in particular, new material discovery. It'll not be just traditional areas that are well covered by classical computing or computers as we know it today, but in areas where drug discovery becomes much easier, because we are hitting the realm of really, you can emulate and simulate the discovery of materials by physics itself. That's really the exciting aspect of quantum computing, which is you are computing with nature itself. Thereby, you don't have to model these phenomenon by equations, which is what we do with classical computing. But with quantum computing, you can really model the behavior of materials and discovery and exploration of new materials and compounds by nature itself. And as I said, the areas I'm most excited about are in materials discovery, drug discovery, and chemistry, materials, drugs, pharmaceuticals, and beyond. At least that'll be the beginning one where most of the impact will be felt by industries.
So you think pharmaceuticals will see a direct beneficial addition from quantum computing in the next 5 to 10 years, or is it 2 to 3 years? What type of time frame do you see?
I would really say from a large impact, from an impact point of view, 5 to 10 years. I think from an exploration point of view, you will start seeing it in next 3 to 5 years. As Cleveland Clinic and Mayo Clinic and others start to experiment a lot more with it. So experimentation is starting to happen now as we start to scale quantum computing further. But from an impact point of view, that materially will be felt by consumers, I would say, will be more in 5 to 10 years.
So if I'm, ABC Pharmaceutical with a $100 billion market cap, do I purchase a quantum computing machine from IBM, or do I lease one? Or is that how IBM plans to profit from this new technological generation?
Yeah, so the way it is really currently structured, and we are in the very early stages of that era, is you can certainly get into partnerships with IBM quantum systems right now. You can certainly lease time on some machines as well. We have obviously established quantum systems or quantum computing systems in several research institutes. Like we are doing Fraunhofer Institute in Germany, one in Japan, with the Mayo Clinic and others. So we are doing these sort of centers, if I may say, for some really leading institutions to start experimenting with them. But you can also lease the time in terms of we have several of these systems available in the cloud, and you can lease time on them. You can experiment with them with APIs and so on. And even more importantly, I would say it's not just about the infrastructure of quantum computing systems themselves, but it's also about the software that goes along with it, because it's about making it consumable by general researchers who really are not experts at quantum computing itself, but are expert at the applications that they deal with.
And how do you compare your progress to Google's at this point?
So I think from the point of view of, again, there are many players in this area, but from the point of view of making quantum systems practical, we just announced a 127 qubit system. We are the only company that have these systems available for people to experiment with on a general consumable basis. So we are significantly
127 qubits is just unbelievable. It's such an amazing amount of power.
And in 2 to 3 years, we actually not just announced 127 qubit, we also put a roadmap of how we are going to be progressing in next several years to come, and we expect to have more than 1,000 qubit in 2 years time, roughly speaking. So we are significantly accelerating the roadmap of quantum computing as we move forward. And we believe we are really leading in that area, not just from a computing power point of view, as you said, Alex, but also from the point of view of having these systems be consumable and available to general purpose developers, software developers as well, who are not expert at quantum computing itself, but are expert at the applications, as I said earlier.
IBM has done so well with the cloud the last few years. Do you think in a few years the quantum division could be the largest in IBM? I mean, this is such an amazing power that you guys have. I hadn't even really thought about what the market desire was for the quantum computing, but when you think about it, really any firm that does significant research, from materials, as you mentioned, to any biotech, to any healthcare, is going to want to use quantum computing. And even those that might not even need quantum computing yet will still want to experiment to see if it's worthwhile. There's so much excess cash flow these days where companies don't know how to deploy them. So it's, IBM is going to once again lead the pack in offering the business world the best in computing abilities.
Yeah, and I think we said few examples, like obviously pharmaceuticals and materials discovery. Finance is another one. There are obviously JP Morgan and several other institutions who are working with us, are exploring applications of quantum computing to financial instruments and risk analysis and other areas as well. So obviously we are in the early stages. Think about the era when we were transitioning from really relay-based computing systems to transistor-based computing systems. Just walk back 50 years. We are in the early stages of that era, and you're going to see phenomenal progress in this area as we move in next 5 to 10 years. I get goosebumps just thinking about what will happen in next 50 years. You see these things in science fiction that will become true, actually.
No, you should get goosebumps. This is unbelievable. The quantum computing has so many uses. I've studied it. I think that finance, has its limitations, but that's because I think finance in many ways is kind of a simplistic, puerile, because it's driven by human emotions. It can't get that complicated. Do the creatures want to sell, or do the creatures want to buy today? And it's almost, there's a level of complication where you kind of hit a wall. But when you get to material development, when you get to figuring out energy conversion, and when you get to figuring out, I think about, United Healthcare, for instance, and the uses that they could have with quantum computing.
Environmental, carbon neutral materials that can absorb carbon actually in the atmosphere. Climate crisis is a major crisis that we are dealing with, and we see the effects of it on an everyday basis nowadays. That news has become a lot more frequent across the world in last decade or so. And just think about the materials that can solve us some of that sustainability problem.
No, IBM can help companies develop extremely sustainable materials to make the world a much better place. The more I think about it, wow, actually, it's such a mechanism for creating more combustible materials that can be composted. The idea for styrofoam to be removed from our society in total would be fantastic as a conservationist. Was this built at the pyramids in Westchester, the famous IBM headquarters?
Yeah. So it's built at IBM research headquarters in Westchester County, New York, known as Thomas J. Watson Research Center, which is IBM research headquarters as well. That's the place I work at too. Modulo COVID, but that's the place I work at too. But yes, exactly. It was built there. We have actually several of our systems up there running physically there as well today. And the scaling has happened there itself too, actually. So yes.
Yeah. So I guess I'd also like to jump to the metaverse, which has been so in the news recently. Do you have an opinion on the metaverse? Do you feel it's been overdone by the media, or are you very excited about it?
So I would put two hats on it, actually. One as a technologist and one almost as a consumer. We've got ways to go, actually. It's very clunky right now. I think a true metaverse experience will be extremely phenomenal to have, but technology has ways to go before we get to a very much an immersive experience, whereby things are, how should I say it, like a lot more transparent. I don't feel like I'm hitting a boundary. It's almost a continuum that exists. And right now the technology is too clunky. You put on these big glasses, actually, you look at Oculus or anything else, and still the experience is very clunky at this point in time. So I would say yes, I think the media is hyping it up beyond where the technology exists today. But I do believe, I think the potential of it as we move more towards a more transparent, more continuous experience for many industries, including some of the challenges that we are facing in our society. For example, we are in many ways, the digitization has been accelerated by the current pandemic we are in right now. And think about education. Obviously the children nowadays are suffering a tremendous, I would say almost, we have stepped back in terms of their mental health, in terms of their education. That has been more and more published recently. If we truly had a immersive metaverse experience, that could have been tackled a lot better. But again, I think we are much further away from it than what some companies will lead you to believe right now that we are there yet. I do believe, I think, given the investments going on in this area, the more progress will take place at an accelerated pace. Having said that, it is also bound by the computational power that is available both at the edge and also in the cloud as well. I think computations are critical to it, because the more complex the experience gets, the more computation power it's going to need as well. And potentially, technologies like quantum computing also has a intersection there as well as we move to more in the future.
Is IBM tackling edge computing?
Oh, definitely. Maybe we are looking at edge computing, not just from the point of view of from an application provider point of view, but more from a technology provider point of view. Distributed computing at the edge, distributed data at the edge. How do you manage data which is distributed both at edge and in the cloud? How do you keep that in sync? How do you govern the data? How do you govern the compute? And so on. So we are looking at it more from an information technology and infrastructure and software point of view, rather than applications point of view, actually.
But aren't the answers to those questions different for every client of IBM's, whether you're Verizon versus a state toll authority?
There is a software stack that cuts across, which is common across you can think of it as you can normalize this across various clients. And then as you get closer to the applications, yes, it becomes very much a client specific. But for example, management of data at the edge, governance of data, and making sure the data is in sync with your central data, all of that, those are common requirements. And syncing of data and the compute, those are common requirements that cut across various applications, and then applications get layered on top of it.
So what's your feeling on no code machine learning? Do you think that's going to spread like wildfire?
Yeah, so I think I really come from an automation background, and I truly believe, this is, I say this usually, that the definition of a job of an engineer is to put himself or herself out of a job. And automate the heck out of it.
That's very well said. I couldn't agree with you more, actually. Yes. Everything, and I felt this way since I was 6 years old, everything that could be or can be automated should be automated.
Yeah, and again, I think it has broader implications for society, and we should figure out how we want to spend our time as a society, because the value will increase the higher you move up in the stack in terms of the creative aspects of what we want to do. But I would even go one step further. Everything that can be automated will be automated, whether we like it or not. It's just a question of time. It will be automated because there are enough productivity and I would even say investment reasons for it to get automated. Second one, I would say, will be in terms of no code machine learning. Absolutely, I think that trend of no code machine learning, low code software engineering, we will start interacting with machines more and more with interfaces that we feel very comfortable with, like textual interfaces or verbal interfaces. It's again, I'm going to go back to some of the science fiction aspects that we have seen from Star Trek onwards. It'll become a lot more interactive. It'll become a lot more automated. And this is again where the power of computations comes in. That the search space can become very large from an algorithmic point of view. But this is where quantum computing driven machine learning becomes even more important too, that it puts the power of quantum and scaled classical together at your fingertips, enabling you to automate the search space exploration much more efficiently, thereby making no code machine learning much more viable and transparent, versus where we are right now, where it could take days as an example, versus it could be minutes as we move forward.
But do you think this will also open the door for a lot of nefarious activity? The hackers of tomorrow will be able to use low code machine learning to locate, who has a pacemaker, and then send you a text message saying, we found your pacemaker, and we'll turn it off unless you send 2,000 quid. So do you think that we're going to enter a new kind of cyber crime world? Recently, members of the government have said that the US is really not prepared for the next wave of cyber crime. So I was wondering if you have an opinion there.
So I think anytime there are new technologies, there are two aspects of that technology. There are nefarious elements that are going to exploit that technology. And there are, obviously, elements that are trying to utilize that technology for, good of the society. It's always been that way, whether it is a weapon, whether it is fundamental physics or nuclear physics. There are always elements that are trying to exploit it, and there are always elements that are trying to benefit the society. Having said that, I believe I believe in the fundamental good of the collective good of humankind, that there are a lot more good elements than there are bad elements. And there are a lot more creative good elements than there are bad elements. And the collective creative power of the good elements will far exceed the power that bad elements may have in this particular case, thereby having the elements or having creative people to detect protection mechanisms that keep always one step ahead of nefarious elements in this case. And I would almost say it this way: it's not that potentially there will not be breaches that will take place. There will be breaches, as there are breaches. There have been breaches all the time, all along. But I do believe that from every breach we learn, and no code machine learning will make it a lot better for the broader creative set of developers to invent a lot more newer methods through which we can protect the infrastructure, whether it is pacemakers or whether it is other devices at the edge, whether it is our cars, as an example. So I truly believe no code machine learning will get the power of machine learning in the hands of developers who know those applications very well, thereby to be able to devise machine learning models that are more robust by definition. Right now, they're developing machine learning models, whether we like it or not, but they are developing machine learning models, and they may not have the protection mechanisms inbuilt in them as well. But no code machine learning will enable such characteristics of the machine learning models to be more more accessible to broader set of developer population.
So this might be a puerile question, but shifting back to quantum computing, can quantum computing be used for better human to computer generated conversation? So the way GPT-3 has been impressing people, can IBM use quantum computing to create a computer that can have impressive conversations with human beings?
I would the models, the kind of models that GPT-3 transformer-based models are built on, they are now called, there's a general terminology for it called foundational models, which are very large, parameterized, literally getting into hundreds of billions or trillions of parameters.
Yes.
I really believe quantum computing itself is a little ways away from overtaking classical computer for generic problems. It'll be the combination of quantum computing and scaled classical computing, which will give us the power where the interactions between humans and machines becomes much more seamless. So whether we are there yet in terms of transformer model GPT-3 or its follow-ons, not yet exactly, but I do believe we will see a lot faster progress in this area, specifically the area of classical computing and quantum computing combined for machine learning applications as we move forward. Again, in some selective domains, because it depends on the domain as well, but I wouldn't say we are there yet in terms of whether it is GPT-3 or its follow-ons, but in certain other areas, you are going to see a lot more progress, specifically the areas that we mentioned very much in the beginning of our conversation, in terms of like materials discovery. And it's all about data exploration, finally. It's all about finding patterns, and which patterns are more aligned with the properties of the materials that you are, desirable properties of the material you are trying to discover.
I mean, but to the young generation out there, when they think of gradient descent versus quantum computing, can you put into a numerical sense how much more successful quantum computing will be than simple gradient descent?
It's again, I think it's hard for me to say just in quantitative terms today if quantum computing will exceed the classical systems we are working on as we speak right now, because we have algorithms that work very well on classical systems. We haven't yet reached the place where we have I would almost say robust computations available with the right coherence time and with the right error rates being reduced as well. I think the quantum technology needs to improve much more for me to be able to get to a point where I can produce a robust model like GPT-3, where the technology is not there yet. I think we are very much in the exploratory phase of that.
But we're at the dawn of the dawn, and to bring it back to Star Trek, the undiscovered country really excites you, and the possibility for quantum computing is just such a gigantic universe, really, and we're just at the very beginning of it.
Yeah, so I think just maybe putting it in the context of some numbers, you will be able to do computations, and whether it is AI based computations with gradient descent or other algorithms in, I would say, days that you will not be able to do with classical computers in years, if not more. It could be hundreds of years, or not even feasible to do it because the energy consumption will be so large. So it will be infeasible. But just in terms of, even if you could gather the resources, it will take you really years to hundreds of years, versus you could do the same computations in days, because you really are emulating the computation with nature itself.
So the particle physics world should be very excited about quantum computing and what potential is there.
Yeah, I think again, leading institutes of the world, whether it is obviously Quantum Initiative at Harvard, or areas at MIT or others, I think this is where the physicists get really excited about the applications of the work that they have been doing for very long, and the impact it can have. In fact, it reminds me of very early days of computer engineering itself, or electrical engineering itself, which was in the Department of Physics, interestingly. There was no separate field called computer science or computer engineering or electrical engineering. It was all within the domain of physics, actually solid state physics at that time. So interestingly, a lot of these step functions happen within the domains of physics, and when they scale, they really move into other areas, obviously starting with computer engineering, from a software point of view, computer science, and broader in application domain. But I think I would even argue most of the fundamental advances come from physics in many ways, and mathematics, obviously.
Awesome. So we're going to have a great new world opened up from this technology that IBM has been doing. And it's great to see IBM coming back and leading the technology world. I'm a huge fan of IBMs, and really honored to have had you on. You're a great mind, and I thank you very much. This was a fantastic conversation.
Well, thank you, Alex, and it was a pleasure to discuss this with you. And we are looking forward to not just, I think, IBM making a massive impact, just like it has in its last 110 years. It has defined the transitions of computing for decades. We are looking forward to leading that transition to the next era of future of computing, which is quantum computing, merged with some of the very critical areas that are going to impact the society in terms of materials discovery, drug discovery, and beyond, and combined with really the software. We shouldn't forget about software, because you can always create any technology, or you can create a technology, but if you don't make it consumable enough, there are only few people there who can use it, and then you can never scale it. Actually, it's about consumability.
No, 100%. Neo Geo, the great video game company, is a case study of what you just said. Everything you said was quite wise tonight. And again, thank you so much, and stay safe during these crazy times.
Thanks, Alex. Stay safe, and Happy New Year to you and to your audience as well.
Thank you. And I hope we bag you to Cornell for a guest lecture.
Thanks.